Subtracting rational expressions with unlike denominators is just like adding them. First, you have to do the work to actually find the common denominator. I can see that that first fraction that denominator can't really be factored, but I see that this one can be. So again, when you look at those denominators and you see what's missing, they already both have 1x. So this guy is missing that extra x. So what I want to do is change the denominator by multiplying the top and the bottom by the missing x, and I'm going to end up with 2x over x squared minus 13 over x squared. Now that I've done the work to get them to be the same, I can just go ahead and subtract that numerator, which is just going to be 2x minus 13 over x squared. 2x minus 13 can't be factored. There's nothing to simplify here. That would be my final answer. In order to subtract this rational expression with unlike denominators, we need to break the denominators down into factors so that it's easier to see what's missing. That first fraction doesn't break down into anything, but I can see the denominator has a common factor of x, and when I take that out, I'm left with x minus 6. Now it's pretty easy to see that the second fraction has 2 factors and the first fraction only has 1. The first fraction is missing the x minus 6. So I'm going to use that to multiply at the top and the bottom to give me a new fraction. So I'm going to have x minus 6 over x times x minus 6 minus x over x times x minus 6. Again, once the denominators are the same, you can just simply add or subtract the numerators by combining the like terms. Don't forget this is minus x, so x minus x means the x's disappear, and I'm left with a negative 6 in the numerator, and my denominator is x minus 6. Again, you can multiply that through if you want to. These are equivalent answers, but I'm okay with that one. In order to subtract this rational expression, we want to factor each denominator first so we can see what's missing to give them common denominators. So I'm going to just factor that first one, which thankfully both of them are easy trinomials, right? The leading coefficient here is 1, which means there's not a whole lot of possibilities of what the answer can be. I'm going to get x and x, a minus and a minus, and the only factors of 2 are 2 and 1. I'm going to get x and x, a plus and a minus. And the only factors of 8 that subtract to give me 2 are 4 and 2. I'm just going to bring everything else down. Now I can see what's missing. So I can see in the first, what they have in common is they both have x minus 2. So I'm going to multiply each rational expression by the piece that's missing. This one over here is missing the x plus 4. So I'm going to multiply the top and the bottom by x plus 4. This one here is missing the x minus 1, so I'm going to multiply the top and the bottom by x minus 1. It's going to give me a new rational expression, which is x squared plus 4x with a really large denominator right, minus, this is going to be 17x minus 17 with a very large denominator. Okay, now it's just going to be a matter of combining like terms. Now what you have to watch out for is that it's minus this whole expression. So that means that this minus sign gets applied to both terms. All the other examples we did of subtraction, there was only one term there. But this has two. You want to make sure that minus sign goes to both of them. So what I'm really going to have is x squared plus 4x minus 17x plus 17. Notice how I changed the signs. I'm going to continue. I'm going to combine like terms. I'm going to get x squared. These combine to get negative 13x plus 17. So that is my answer for the numerator. So here I am writing my final answer. X squared minus 13x plus 17 all over x plus 4, x minus 2, and x minus 1. I could try to factor that, but I know there are no factors of 17 that are going to give me 13, so that would be my final answer.